This is the Calculus AB Practice Final A, no calculator. So let's get to it. Number one is giving us a limits problem. So what we need to do first is plug into infinity. So that's going to be 4 times infinity minus 2, 3 minus infinity over x plus, no, infinity plus 1. And 4 minus 2 times infinity. So that's just going to give us infinity over infinity, which is indeterminate. So now we're going to apply L'Hopital's rule. So let's apply L'Hopital's rule. So how do you apply L'Hopital's rule? You're going to find the derivative of each component. So we're going to find derivative of this, and these two. So now, what is the derivative of 4x minus 2? Derivative of 4x minus 2 is 4. The derivative of 3 minus x is just negative 1. The derivative of x plus 1 is just 1. And the derivative of 4 minus 2x is negative 2. This negatives cancels out, which just leaves us to 4 divided by 2, which just gives us with 2. And our answer is going to be C. Number 2 is one of your integrals. So what we could do here is rewrite this as x to the 1/2 dx. And then next, we're going to do the anti-power rule. And the anti-power rule says it's going to be x to the 1/2 plus 1 divided by the new power. So the anti-power rule says that you add 1 to the exponent and you divide by that new power. So 1/2 plus 1 is going to be 3/2. And let's clean this up a little bit. That's going to be x to the 3/2. And then since you have a fraction in the denominator, we're going to have to rewrite that as a product of its reciprocal. So it's going to be 2/3. Let's rewrite that as a root. So it's going to be x to the 3/2 plus c, because this is a definite integral. So this is your answer. So your answer is going to be 2/3 to x to the 3/2 plus c. So our answer is going to be B. 3 is if f of x equals x plus 1 squared times x squared minus 2, then f prime of x is, so it's asking for the derivative of this. They're both multiplying by each other, so we're going to have to apply product rule. So it's going to be right times derivative of the left plus left times derivative of the right. So our right is going to be x squared minus 2. The derivative of the left is going to be 2x plus 1. Power rule and chain rule, but the chain rule doesn't really apply here because we're just dealing with x, plus our left function, which is x plus 1 squared, times the derivative of the right, which is going to be 2x. Now, we can factor this. We can factor two things that are noticeable here. We can factor out a 2x, not a 2x, 2, and a x plus 1. How can we rewrite that? Well, we're going to rewrite it like this. So it's going to be 2 x plus 1 And we're going to bracket that is going to be x squared minus 2 plus x plus 1 times x. It should look something like this. And now we're going to simplify that. So it's going to be 2x plus 1 is going to be x squared minus 2 plus x squared plus x. And all I did here was distribute. I wrote that wrong. And that's basically what I did. So let me write that second step. Now, what we're going to do is simplify. And now we're going to leave the 2x plus 1 as is. And we're going to combine like terms. So it's going to be 2x squared plus x minus 2. And that is our answer. You cannot... the answer key, or the answers given here, doesn't really simplify it all the way. So D is our answer. Number 4 is a sum of two possible integrals. We can split this into two. So it's going to be e to the 2x dx plus secant square root of 2x dx. So our first step was split integral. And then our second step, solve for left integral first. Let's do this step by step. So it's going to be e to the 2x. You can u sub this. Let's use blue. U is our 2x. Du is 2dx. Du, we derived that. And what we do now is we cannot have constants on the right, and we need to bring our constants to the left. So we're going to divide both sides by 2, which that is 1/2 du equals dx. And now we are going to rewrite this entire integral. So it's going to be e to the u times 1/2 du. I would prefer bringing your constants in front of the integral so things don't get messy, which is going to be 1/2 e to the u du. And now we're going to simplify that. It's going to be 1/2 e to the 2x. And this is our left integral. Now we're going to do right integral. We're going to integrate our right function. So it's going to be the antiderivative of secant of 2x dx. Our u value is going to be whatever is inside the parentheses. So it's going to be 2x. We're going to do the exact same thing as we did with the left integral. That way it saves time. And it saves the explanation necessary for the u substitution process. So now we're going to put everything back together in terms of u. So it's going to be secant squared of u times 1/2 du. Bring that to the front. It's going to be looking like this. And now we are going to simplify that. The antiderivative of secant squared of u is going to be tangent of u. And now we get to bring back our x. So it's going to be 1/2 tangent of 2x. Number 4, combine answers. So it's going to be 1/2 e to the 2x plus 1/2 tangent of 2x plus c, because this is an indefinite integral. And which answer choice matches what I wrote down here? It's going to be A. 5 is another L'Hopital's rule problem. So we're going to put 0 into everything here. So it's going to be 15 times 0 minus 4 times 0 squared over 3 times 0 squared minus plus 9 times 0. Anything multiplied by 0 is going to be 0. So it's going to be 0 minus 0 over 0 plus 0, which is going to be 0 over 0. So this obviously is indeterminate. So we're going to have to apply L'Hopital's rule. So now we're going to derive everything. The derivative of 15x is going to be 15. The derivative of negative 4x squared is going to be negative 8x. The derivative of 3x squared is going to be 6x. The derivative of 9x is going to be positive 9. So we're going to plug in 0 for that. So it's going to be 15 minus 8 times 0 over 6 times 0 plus 9. Anything times 0 is going to be 0, so we can just cancel those out and ignore them, which just gives us 15 over 9. These are both divisible by 3. So we're left with 5/3 as our answer. And that's going to be D. D is going to be our answer. Moving on to 6. Let f be the function defined above. Which of the following statements about f are true? Number 1, f has a limit at x equals 4. So what this means is that you got to plug in 4 into wherever you see equal sign in your inequality. So as you can see, this has an equal sign here. So we're going to plug in 4 into that and see if we get a number. So basically, it's going to be 2 times 4 minus 3. It's going to be 8 minus 3, which is 5. 5 is a number, so condition 1 is true. Number 2, f is continuous at x equals 4. What this means is from the two-sided limit is equal to each other, is equal. So basically, plug in 4 to both equations and check if values are equal. Okay, so it's gonna be 2. It's gonna be 2 times 4 minus 3 equals 13 minus 2 times 4. So 8 minus 3 equals 13 minus 8. That's gonna be 5, and that's also gonna be 5. If they're both equal, that means that condition 2 is continuous. We're gonna check that off. So far we can do process of elimination and say it's not going to be 2 only, it's not going to be 3 only, it's not going to be 1 only, since 1 and 2 work so far. So we are going to now test if D is the answer or if E is the answer. So now we're going to check if f is differentiable at x equals 4. That means two-sided limit is equal, but this time you're going to plug in 4 to both derivative equations. So now, what is the derivative of the left side? The right side? Doesn't really matter, since we're both testing. They're both going to be set equal to each other, so they're going to be possibly worth the same thing. What is the derivative of 2x minus 3? The derivative of that is going to be 2. and we're going to set that equal to the derivative of the other function on the left side, which is 13 minus 2x. The derivative of that function is going to be negative 2. Is this true? No. So third condition is not met, so our answer is going to be D. Only condition 1 and condition 2 are true. Number 7. A particle moves along the x-axis with velocity given by v of t, 3t squared plus 6t for time t is greater than or equal to 0. If the particle is at position x equals 3 at time t equals 1, what is the position at t equals 2? So remember that position is represented by the x of t function. That should be on your cheat sheet, and you should remember doing this from particle motion. But we're just trying to solve for x of 2, so this is what it's going to look like. So what I'd like to do first is identify what is the question asking for. And then 2, you're going to identify the formula or the setup. So for these types of questions, whenever you find the original function at a certain given point, remember that you're always going to have to use the initial value at when it's giving you a time. So it's going to excuse me. So our starting point was at t equals 1 at position 1. So that's going to be put like that. Then you're going to add the integral from 1 to 2, since we're calculating the position, and that is the antiderivative of velocity, so, or the integral of velocity, and we're given our bounded limits here because of our given and our question. Remember that the given value is always at the lower limit, and the one that we're solving for is going to be at the upper limit. So now what is the slope again? It's going to be v of t dt, but I'm just going to write it as 3t squared plus 6t dt, since we're not allowed to use a calculator. You could use a calculator if it lets you, and that would save you a few seconds of your time, but we're not allowed to use a calculator for this section. So now 3, you're going to plug in everything. You're going to plug in variables or numbers. So now it's going to be x of 2 equals 3, because at time t equals 1, it is at position x equals 3, plus the integral from 1 to 2, 3t squared plus 6t dt. Our fourth step is going to be integrating. So the antiderivative of this, let's put the little bar there, is going to be, using anti-power rule, is going to be, you're going to add 1 and divide by the new power. 2 plus 1 is 3, which means that that cancels out. So that's just going to be left with t to the t cubed. And then for this one, you're going to add, there's a hidden 1 there. You're going to add another 1 and divide by that new power, which is going to be 2. 6 divided by 2 is just going to be 3. So it's just going to be plus 3t squared. And now we're going to apply the fundamental theorem of calculus. So basically the fundamental theorem of calculus says if you have a definite integral, how that works when you apply that to function is you apply the upper limit applied to the function minus the lower limit applied to the function. So that's going to be 3 plus 2 cubed plus 3 times 2 squared minus 1 cubed plus 3 times 1 squared. And now we're going to simplify that, and we should get our answer. So it's going to be 3 plus 8 plus what is 2 squared? That's going to be 4. 3 times 4 is 12. Minus what is 1 cubed? That's going to be 1. 3 times 1 squared. 1 squared is going to be 1. And 3 times 1 is just going to be 3. So it's going to be 1 plus 3. We're going to simplify this. It's going to be 20 minus 4. It's going to be 16. 3 plus 16, which is going to be 19. Our answer is going to be 19. Our answer is C. Alright, so this question says if f of x equals sine of 2x, what is f prime of pi 8? So first, derive. So it's going to be f of x equals sine of 2x. This is going to be chain rule, so it's going to be cosine of 2x times the derivative of the inside, which is 2. Because remember that it's going to be f of g of x, the derivative of that is going to be f prime of g of x times g prime of x. This is our g prime, this is g, and this is f prime. This is how we got our answer, or our answer to our first step. So it's going to be 2 cosine of 2x. And now, second step is to plug in pi 8 for all x. So it's going to be, oh, I forgot to put the prime. So it's going to be f prime of pi 8 is equal to 2 times cosine of 2 pi 8. This can be simplified to pi fourths. 2 cosine of pi fourths. Cosine of pi fourths is going to be root 2 over 2. Those 2's cancels out, and that gives you root 2 as your answer. And that matches option A. Our answer is going to be A. For number 9, the graph of the piecewise linear function f is shown in the figure above. If g of x is this function right here, what is the least candidate, or what is the least value? So we're given this graph here, and what you guys could possibly notice is that this can be divided into areas of shapes. So let's calculate. So our first step is calculate area of shapes. So there's going to be one triangle here. So that's going to be base times height divided by 2. Our base is 1. Our height is going to be 2. 1 times 2 is 2. And divide that by 2. Our area is going to be 1. This triangle can be, this is another hidden triangle right here. It's the exact same area because it has the exact same shape. But in this situation, it is below the x-axis. So the area is going to be -1. Over here, we have 2 trapezoids here. And the area of a trapezoid is going to be base 1 plus base 2 divided by 2 times the height. So our base 1 for this trapezoid here is going to be 1. Our base 2 for this trapezoid is going to be 2. 1 plus 2 is 3. 3 divided by 2 is our base 1 plus base 2 divided by 2. And now we need to multiply that by the height. So it's 3 divided by 2 times 2. No, not times 2. Wait, is it? Yes. So it's going to be 3 halves times 2, which is going to be 3. Alright. So let's double check our math there. So it's going to be base 1 is 1. Base 2 is going to be 2 divided by 2 times our height, which is going to be 2. Yep, that is correct. So for this one, it's going to be base 1 is going to be 1. Base 2 is going to be 2 divided by 2 times our height, which is going to be 1. It's going to be 3 halves. this trapezoid is going to be 3/2. So, plugging into g of x here, what is g of 3? What is g of -3? And what is our least values? So, I want to do this one by one. So, let's start with option A, g of -3. So, let's plug that into g of x. Whoops. What happened to my edits? Where did everything go? Right here. Okay, I don't know why it went to preview. G of -3 is gonna go to G of. Is gonna go from here. It's gonna go from 2 to -3. I believe that's ft dt. Let me just clear these apps so that it doesn't lag. And it's asking from the area from 2 to -3. So we start here. We're going backwards. So the negative area is going to be positive, and the positive area is going to be negative. So now we're going to do a plug and chug. Alright, so it's going to be 1 minus 1 crosses out, minus 3 minus 3/2. That's going to be simplified to -9/2. And right now, this is a very strong least value, but let's test the other candidates. So it's going to be, let's look for candidate B, g of -2. So it's going to be going from 2 to -2. So basically, it's still going to be the opposite area since we're going backwards. It's going to be 1 minus 1 minus 3. That's going to be -3. Immediately after checking this value here, -9/2 is lesser than -3. So we can cross off option B. So from C, we're going to do g of 0, which is our third candidate. From 2 to 0, we're still going backwards. What is our area? So from 2, we go plus 1. And from 1 to 0 is going to be -1. And that cancels out to 0. So that's going to be 0. G of 1. Oh, this is still not our least value. So right now, A is our possible answer. D. G of 1. We're still going backwards. So our area is going to be negative. So from 2 to 1, what is our area? That's going to be +1. This is still wrong. It's not our least candidate. So E is our last candidate. And E is going to be G of 2. So from 2 to 2, f of t dt, our area is going to be 0. Why? That is because we have not moved at all, because we just went from 2 to 2, and that doesn't do anything. You don't move, so 0. That our least candidate is going to be A, which is going to be our answer choice here. G of -3 is our least candidate. And by the way, if you can figure out the bigger picture here, if you calculated the area, you could tell that the greatest area was from was going all the way to the edge backward, so that you could, so whatever candidate went all the way to the back, that was our least candidate. Just letting you guys know. So for 10, the graph of function f is shown above from domain 0 to 3. Of the following, which has the greatest value? From 1 to 3, f of x dx. So it's saying from 1 to 3, this has f of x, the area, from 1 to 3, we're going to look for the area of f of x. So it should look something like this. This is the exact value. And we're trying to look for the most amount of area possible, or the greatest value possible. So from left Riemann sum from 1 to 3 with two sub-intervals of equal length. So basically a left Riemann sum means the left controls the height. So from 1 to 2, 1 controls the height, which at 1, this is our point. That controls the height of 2. At 2, this is our height. So that's going to be the height of 3. As you can see, this is not the greatest value so far, because it is an underestimate because of the increasing function. So B is off our radar. Now we're going to do right Riemann sum with two subintervals of equal length. So what this is basically saying is the right controls the height. So we're going to start at 3 because it's from 1 to 3. Oh, I forgot to write my steps. Evaluate each option. So we're gonna start here, and this is basically saying the height of 3 controls the height of 2, because the right controls the height. And that's our area. And now we're gonna go from 2 to 1. What is the height at 2? This is the height at 2. This controls the height of 1, meaning this is an over approximation. So that gets rid of option A, since this has a higher value of area. Midpoint Riemann sum with two subintervals of equal length. The middle controls the height from the left coordinate and the right coordinate ahead of it. So basically saying the middle point controls the height. So 2 controls the height. So we're at 2. It's basically controlling the height for this. This is an underestimate, and this is not our greatest area or our greatest value. So we can cross C and D off the options. A trapezoidal sum from 1 to 3 with two subintervals equal length. So basically, we're going to draw mini trapezoids here. And by the looks of it, this is going to be a very narrow trapezoid. It's similar to option A, where it's going to be the exact value. So that's still not going to be our greatest value. So, oh wait, why did I cross out C? My apologies. C is going to be our answer because of the over approximation or overestimate that it provides. 11. The graph of f is shown. Which could be the possibility of graph f? So let's mark down the observations that we see. So from negative infinity, so 1, so from negative infinity to 0, so from here to here, f is increasing, meaning f prime is greater than 0. Okay? So from 0, let's name this point C. So from 0 to C, f is decreasing, meaning f prime is less than 0. Alright? And then from C to positive infinity, f is increasing again, meaning f prime is greater than 0. So which of the options matches the observations? So number 2, match. So let's see. From negative infinity to 0, f prime is great. From negative infinity, is f prime greater than 0? Yes. Why? It's because since we're already on the graph of f, we just need to check if the interval is either on the top of the x-axis or on the bottom of the x-axis. That's how function analysis gets people confused, is because people cannot differentiate the comparisons of the slopes and intervals of f and f prime. So don't get used to f or f prime. Don't get used to one, get used to both. So we're on the graph of f prime, by the way. These options are all f prime, the graph of f prime. So now we're going to look at interval, not slope. So from negative infinity to 0, f is increasing, or f prime is greater than 0. This is true. From 0 to c, f prime is decreasing. To some point, f prime does decrease, so that matches our second criteria. And from c to infinity, let me mark that down. Yeah, f is decreasing at this interval here. And from, let me color code it. And from c to infinity, is f increasing? Yes. Why? It's because f is above the x-axis. So that means that f is increasing. F prime is above the x-axis. So A seems like our answer for now, but let's double check on the other ones to prove they're incorrect. So let's check B. From negative infinity to 0, f prime is above the x-axis. So from here to here, wrong color. From here to here, this is not the case because f prime goes from above to below the x-axis before they reach 0. So B is not our answer. For C, same thing. From negative infinity to 0, it touches both intervals. So this is not the case. For D, from negative infinity to 0, f prime is greater than 0. So it should be above the x-axis. It's below the x-axis from negative infinity to 0. So this is wrong. For E, same thing. From negative infinity to 0, it's still below the x-axis when it should be above. So our answer is going to be A. Once you connect f and f prime and you can identify similarities between both graphs and how to identify what the question is asking for, function analysis is not that bad. For 12, it's asking for another derivative, and this is another chain rule problem. So, number 1, chain rule. I'm going to abbreviate that. So the chain rule says we're going to find the derivative of the outside while leaving the inside alone. So it's going to be, and then multiplying by the derivative of the inside. So the derivative, so this is going to be f of g of x. And remember that f prime of x is going to be f prime of g of x times g prime. So we're going to find the derivative of f. The derivative of f is, so f is cosine. The derivative of f is negative sine. So that's going to be negative sine. Leave g alone, or basically leave the inside alone. And then multiply it by the derivative of g, the inside. The derivative of ln is just 1 over x. And then this can be simplified to negative sine of ln of x divided by x. And that matches option B. And 13 is f of x is, if f of x is equal to x minus x squared, what is the derivative of f? What is the derivative of f of e to the x? So basically, what is this question asking for? This is another chain rule problem. So this is going to be f, this is going to be g, and remember that the derivative of f of g of x is going to be f prime of g of x times g prime of x. So basically, I forgot to write the steps. Well, not really. Well, I didn't go in depth. The step for this is just apply chain rule. So what is f prime? F prime is going to be f prime, ironically, or unironically. Anyways, leave g alone, and that's going to be multiplied by the derivative of g prime of x. The derivative of g. So that's going to be, this is the derivative of the inside. The derivative of the inside is going to be e to the x, because the derivative of e to the x is itself. So that's how it should look like. And now we are given f of x. Now we're going to try to evaluate that at e to the x. So let's find f prime. Find f prime. So f prime of x is equal to 1 minus 2x based on power rule and memorize derivatives. And now we're going to evaluate that at e to the x. F prime of e to the x, since there's no function at 1, that's going to be like that. And then we're going to subtract it by 2e to the x. We're going to replace x with e to the x. Basically what this derivative is going to say. And don't remember that we're going to multiply by e to the x. So it's going to be we're going to factor that inside. So 2. So 3. Plug in e to the x for all x. Okay? And then 4, factor and simplify. Alright? And my screen is frozen. Alright. So e to the x times 1 is e to the x minus 2e to the 2x, because we have 2e to the x's, and that is going to match option E. Question number 14. The polynomial has selected values of its first derivative, f prime, in the table above. Which of the following statements must be true? So this is a function analysis problem, and we're going to graph f prime of x. So from 0 is going to be negative 4. That's going to be our first point. And we're going to connect all of this in just quite a bit after we have everything plotted down. So it's going to be 1, 0. We're just going to plot every single point. And then 2, 3. And then 3 is going to be 1. So our graph should look something like this. That does not look right. Or something like that. So since this is the we have this little graph here, we can check on which possibilities are correct. Is f decreasing on the interval from 0 to 1? It is, but let's check the other options first. F is decreasing on the interval 0 to 1 because f prime is less than 0 from 0 to 1. So this is true. Oh, f prime is less than 0. Is f increasing on the interval 1 to 2? So is f prime greater than 0? That's also true. Does f have a local minimum at x equals 1? Does it change from negative to positive when it comes to intervals? Yes, but so f prime goes from positive to negative. Negative to positive. This is also true. The graph of f has a local minimum on the interval 0 to 2. So somewhere between here, it does change. It changes from negative to positive. This is also true. So same thing. It's more broad though. Is f increasing on the interval 1 to 3? Yes, because the function from 1 to 3 is above the x-axis. So basically all of these are true, but the solutions say that this is the answer because this is the most specific answer here. So this question is a very tricky question, but I guess you just have to look for the best answer, which could be subjective. So yeah. 15. 1 plus x squared plus 4. This is a very interesting problem because you're gonna have to deal with the arctangent here. So you can factor out a 4 here. Why is that the case? Because here's why. You can rewrite this integral as 1 over 4. You factor that out. X squared times 4 over 4 plus 1. Meaning, what you can do here is when you factor 4 back in, that 4 cancels out. And when you factor that 4 back into the 1, it's going to be 4. So it's going to be x squared plus 4 again, which is why you can simplify this, which you could test if this is reversible or not, but it is. So it's going to be dx. Oh, and I forgot to write the steps here. So the step 1 was to graph. And then 2, compare answers. Alright. Now we can simplify this again by factoring out 1/4 from there, because 1/4 is a constant, and now we can simplify it like this. We can simplify that to x over 2 squared plus 1. So if you do x over x half times x half, you're going to get x squared over 4 again, which is what the previous problem gave. So now we're done doing the fixing. So 1 is rewrite. 2, u sub. Now we can u sub a 2 in there, and x over 2, because that is in the parentheses. So u equals x over 2 du equals 1/2 dx. All right. And now multiply both sides by 2. It's going to be 2 du equals dx. All right. Perfect. Now, what we need to do here is plug everything back in terms of u. So it's going to be 1/4 1 over u squared plus 1 2 du. Move that constant to the front, so that's going to be 2/4 1 over u squared plus 1 du. And 2/4 is going to be simplified to 1/2. And why is... Let me write the fourth step. Or the third step. Integrate. So it's going to be 1/2 tan inverse of u plus c. And now we can bring back the u. And we're going to change that back into x. So it's, u is equal to x halves. So this is going to be our answer. Tan inverse is the same thing as arctangent. So our answer is going to be E. Moving on to question number 16. We have about 14 more problems, I believe, until this is over. So if y equals e to the x times y, what is dy dx? So this is basically saying d over dx, y, we're trying the derivative of this entire function here. So first, 1, derive using implicit differentiation, since we're solving with 2 different variables and we are doing it in favor of one over the other. So do all right. The derivative of y in respect to x is dy dx. Equals e to the xy, but we're gonna multiply by the exponent according to chain rule. So it's gonna be right times d left plus left d right. So it's gonna be, what's the derivative of y? It's gonna be right, right, which is y, times derivative of x is 1, plus the left, which is x, times the derivative of y, which is just 1, but we're doing it in respect to x, so it's going to be dy dx. This is really messy, so let's clean everything up. Dy dx equals e to the xy y plus x dy dx. And now we're gonna FOIL it. Which gives us this. Now we're gonna move that dy dx variable to the left. So it's gonna be like that. Now now we're gonna simplify this, and we're gonna do, we're gonna factor out a dy dx here, so it's gonna look something like this. I'm sorry if I'm cutting out. It's because since this document has so many pages, it's gonna be a little bit the quality, or the how it's running, is gonna be a little chopped at times. So it's gonna be something like this. Then we're going to divide both sides by 1 minus x to the e to the xy. Cancel. And now we have fully isolated dy dx, which is this. And which option is that? That's going to be E. Oh, wait, no. A. Moving on to question number 17. We're given f prime, and it's given horizontal tangents at 2 and 5. When does f have a point of inflection? So that basically means, when does f prime change sign? Not change sign, change concavity. Concavity is basically the fancy term for slope in second derivative language. So we're looking for the change of slope of f prime of x. So when does f prime change slope? It goes increasing from 0 all the way to 2, and then it decreases from 2 to 5, then from 5 to 6 it increases. So it points of inflection are basically like the peaks, or the points of change in slope. So point of inflections are on 2 and 5. So our first step was identify vocabulary. And our second step was matching criteria. for 18 on the xy plane, the line y equals 4x plus k, where k is a constant, is tangent to the graph of y equals e to the x plus 3 to the x plus 3x plus 2. What is the value of k? So now what we need, it's saying that these two functions are tangent to each other. So the slopes are equal to each other. The derivative of 4x plus k is 4. The derivative of y equals e to the x plus 3x plus 2 is e to the x plus 3. And now we're going to do algebra. So first, compare. Find x. Use x to find k. Alright. Now we're going to isolate x. Follow my algebra. Now everything is tied back together. I went a little bit ahead and set the y functions equal to each other so that we can plug in x to get k. Alright? So now we're going to plug in 0. And our answer is going to be D. What are all horizontal asymptotes of this function here? So basically, to find horizontal asymptotes, find common variables. So we have a 5x and a 5x here. And that's, you can cancel those out, giving you 1 over -1, which is 1, or -1. This is our first horizontal asymptote. Now we have to identify the other variable, which is 5 divided by 1, which is going to be 5. So which answer has -1 and +5? E. Alright, just a few more left. And now we're trying to find, let f be a function with second derivative with this value given here. What are all the x coordinates where f changes concavity? So we have 3 possible x intercepts here. So 1, Remember that x-intercepts are also called roots and solutions. So here you go. So it's going to be so these are all possible points of inflection. So now we're going to use the number line to determine if there's a point of inflection at these points. So we're going to check a value when we plug in. We're going to plug in a random value that's before 0 to see what's the sign for this, if it's positive or negative. So let's do -1, since -1 is less than 0, and that can determine our sign for this graph here. I mean, for this number line here. So f double prime of -1 is going to be -1 times -1 minus 1 squared, which that's going to be 2 squared, I believe. So let's plug in -1. Let me show you. And that's gonna, let me just show you the algebra. And the answer is going to be positive for this point here. Now, from 0 to 1, the value in between those points is going to be 1/2. So let's plug in 1/2. I'm gonna visually show you guys the algebra when I plug in f double prime of 1/2. So this is gonna be positive, and this is gonna be negative. A negative times a positive is gonna be negative. So this is gonna be negative from 0 to 1. How about from 1 to 2? Let's use 3/2. 3/2 is positive for x. 3/2 minus 1 is going to be 1/2. And 1/2 squared is going to be 1/4. So that's going to be positive. And 3/2 minus 2 is going to be negative 1/2. So that's going to be negative. Positive times negative is still going to be negative. So there's no sign change. Then from 2 to any value after that, let's just use 3. So 3, that's going to be positive. 3 minus 1 is going to be 2. 3 minus 1 is going to be 2 squared, which is going to be 4. So it's still going to be positive. And then 3 minus 2 is going to be 1, so it's going to be positive. It's going to be positive. So multiplying all these 3 together, multiplying 3 positives is obviously going to give you a positive. So there is a sign change. So your points of inflection are where it changes sign. So changes sign at 0 and it changes sign at 2. Answer C. (21). It's saying that when is the velocity increasing? So this is x of t. And now we're gonna find when v of t is greater than 0. So remember, let's do a comparison. X prime of t is equal to v of t. And velocity is increasing, so v prime is greater than 0. And the derivative, or v prime, is equal to a of t, which is acceleration. So that means that x double prime of t is equal to v prime of t, which is equal to a of t. So here, when is the velocity increasing? So when is x prime of t greater than 0? So basically, if you're given the original function and you're trying to find when the second derivative is greater than 0, you're going to look at its parabola-ish format. So the parabola format is, we're trying to look for when the parabola is going to be pointing up, since it's increasing. Something like that. So it is increasing from 2 to 4, because it's literally shaped like that. Alright? So that's going to be our answer. Alright. So we are given I would call this a logistic equation-ish. Not really. Actually, no. So a bacteria spreads among a population of a number of people at a rate proportional to the quotient of number of people who have bacteria and the number of people who do not have bacteria. So if P denotes number of people who have the number of a number of people who have the bacteria, which of the following differential equations can be used to model this situation with respect to time t, where k is a positive constant? So there's basically n equals actually no, sorry, dp dt. So we're trying to find the derivative, or the rate, of people who have bacteria and people who don't. So let's read the Question. Bacteria spreads among a population of n people at a rate proportional to it. So, um, it says there's going to be a quotient. So let's cross off B, C, and D since there's no division here. And now we're going to multiply the rate of people and the quotient is going to be the number of people who have bacteria and the number of people who do not have the bacteria. So rate is in this case rate is represented by K. This is, for me, this is a chemistry reference. K is going to be multiplied by the quotient of people who have it and people who don't have it. So the number of people who have the bacteria is represented by P. That's going to be a numerator since that was listed first. And if N denotes the total number of people, we could do the total number of people minus the people who have the bacteria, and that gives us the amount of people who, the leftover amount is the amount of people that don't have the bacteria. So basically, K times P divided by the total amount of people minus the people who have the bacteria. So basically, people who don't have bacteria. The answer that best suits this equation here is going to be E. All right. For this question, you have to look at the order of what the question is asking you in order to get the question right. So that way, to prevent any further lag, your first step was to find vocab that eliminates the options that stands out, that makes the other options less likely to be correct. And then now you gotta look closely on what that vocabulary is saying, because order does matter in this type of question. So, and you gotta compare that vocab to the mathematical expressions that the vocabulary is giving you. So this is how you do this question. It's very complicated if you do not read the question carefully. So number 23 is your 4 steps. So first step, separate and integrate. So separation of variables and then integrate them. Write that down. Second step, you find the IC, basically by plugging in so for your second step, you write in plug in initial condition to X and Y. And then your third step is to find Y using your IC. So let's do that all algebraically. All right. So first, we're going to separate. Y goes on the left and X's go to the right. Follow my algebra. Now we're going to reiterate that c back into our simplified variables equation. Square root and since we had our y coordinate 10 is positive, we're going to use the positive option. Our answer is going to be A. Number 24 is asking for an approximation. So we're trying to use a tangent line. So we're basically using y equals mx plus b, or the point slope equation. I will use point slope equation because it is much more simpler. Let's use this. So it's gonna be y minus 2, because it's y minus y1 equals m in parentheses x minus x1. So your first step, put into point slope form, or put your equation into point slope, then convert to slope intercept. Then after that, you replace y with f of 0.1, and then put in 0.1 for all values of x and estimate. Our slope is going to be -3 because the slope, the derivative of 0, the derivative of at x equals 0 is -3. And then plug in 0.1. Use algebra to solve. It's saying we're given another limit problem here. Let's check for continuity, and then let's check for differentiability. But for your steps, for step 1, check continuity and solve for an equation. Then step 2,